Hi, hello friends, welcome to GMK tutorials. So today we are going to discussing most important topic for external point of view, okay, so maybe internal point of view also. So that is nothing but lattice structure realization of a FIR system, okay, lattice structure realization of a FIR system. Generally in the last couple of videos we discussed regarding the structures of FIR structures realization, like direct form realization, cascade, parallel form realization, or transposed form realization. Now we are going to focusing on lattice structure realization of a FIR system. So in that, FIR systems are discussed in general still now. Lattice structure is extensively used in the digital filter, okay. So these lattice structures consisting of two different paths, okay, through which the input is processed. Hence these lattice structures are two different output. That means that in case of the lattice structure, the input is processed through two different parts. That's why in case of the lattice structures also we are getting two types of outputs, that is generally called as a y of n is the y of n is the one, and y prime of n, that is nothing but y dash of n is the second output. Actually y of n output is generally called as a real output, okay. Y dash of n is generally called as a supporting output, which offers support for obtaining the output for the next stage. That means the y dash of n output anedi which is supporting for the next stage to get the output for the next stage, okay. So that is the two important conclusion. After that, single stage FIR structure is shown figure below, where k is generally called as a reflection coefficient. Suppose if you observe this equation here, k1 is there na, like, so this k is generally called as a reflection coefficient, okay. This k is generally called as a reflection coefficient. So the output from the first stage of the output from the first stage of the lattice structure, which is of the order 1, that is nothing but we are considering the first order system. So first order system means that obviously it consisting of only one delay element. So that is one of the most important, guys. When observe chesam the equation lo, so suppose here, let us see here, guys, for analysis point of view. So manaki y1 of n output ela vastundi, y1 of n can be obtained, that is nothing but x of n is passing in this direction, it is added to the adder. After that is also one more path is there. Here x of n is passing through the one delay element, so it is multiplied with k1 and is again added to this adder. Therefore y of n is equal to this one, x of n plus k1 into x of n minus 1. So this is the output. It is generally called as the real output, okay. So second thing is nothing but y dash of n is equal, what are the possibilities for adding, what are the possible input for this adder? First one is nothing but in this direction, that is nothing but k1 into x of n plus, here this is nothing but it is directly added to this one without multiplying k1. Therefore y dash of n is equal to k1 into x of n plus x of n minus 1, okay. So this is the second output, that is nothing but y dash of n. This y dash of n is generally called as a supporting output for the next stage. Alright, up to now it is clear, guys. Intavaraku andariki ardhamaindi anukuntunna, I think, okay. So after that, similarly the two stage lattice structures consider chestamante, so that can be shown in the figure below. The output from the second stage of the figure 2, which is the second order FIR system. That means మన first order system lo chusamante, so it consisting of only one delay element. But if we go for the second order system, so the order represents it consisting of two delay elements. Therefore that's why it is called as a second order system. So in case of the second order system, see this figure very clearly. So if you see the output point of view, what are the possibilities for y2 of n? Y2 of n is equal to this y1 is added to the adder, and at the same time y dash of n is passing through the one delay element, that is nothing but z inverse, and multiplied with the k2 and it is added to adder. Therefore y2 of n is equal to y2 of n is equal to y1 of n, right, plus k2 into y1 dash of n minus 1, y1 dash of n minus. So that is the first output. Second, y2 of dash 1 is nothing but it is the below output, this output actually. So what are the possibilities for getting the output of y2 dash of n is equal to y2 dash of n is equal to, so one is nothing but in this direction, that is nothing but k2 into y1, so k2 into 1, first one. Second one is nothing but here y dash of n is directly added to this one, therefore y dash of n minus 1. So here y1 is there, okay. So y1 dash of n minus 1. So this is the output for the second stage, okay. This is generally called as a two-stage lattice structures, okay. Now we can derive the complete equation. Up to now we have to represent the y2 of n in terms of y1 of n. So generally in the previous here in this case we know that generally what is the equations for y1 of n and y1 dash of n. By using this y1 and y1 dash of n, we can get the y2 of n actually. So y2 of n is equal to this one. y1 of n can be substituted here and y1 dash of can be substituted here. So for that purpose, let us see here guys. So substituting the values of y1 of n and y dash of n in the above equation for y2 of n and y2 dash of n. So ఇప్పుడు ఏం చేసిన y2 of n అంటే ఏంటి మనకి y1 of n plus k2 into y1 dash of n. So y1 of n కి ఈక్వేషన్ ఆల్రెడీ మనకు తెలుసు, x of n into x of n plus k1 into x of n minus 1. So y dash of n is nothing but k1 into x of n minus 1 plus x of n minus 2. So ఇట్లా సింప్లిఫై చేసేసి మల్టిప్లై చేసామంటే ఫస్ట్ టైం ఏమొస్తుంది జస్ట్, సో ఇక్కడ చూసారంటే x of n, సో k1 కామన్గా తీసామంటే k1 1 plus k2 into x of n minus 1, k2 into x of n minus 2 వస్తుంది. సో ఈ ఈక్వేషన్స్లో కూడా మనం y2 dash of n కి ఈక్వేషన్ డిరైవ్ చేస్తామంటే y2 dash of n is equal to k2 into first one plus k1 into this one, okay. So equations derive చేసే same procedure, k1 k2 k1 value కాన్స్టెంట్ని separate చేసామంటే then we can represent the corresponding equation in terms of a k2 into x of n, k1 into 1 plus k2 into x of n minus 1, and third one is nothing but x of n minus 2. Now this equation can be assumed like, let us consider alpha 2 of 0 is equal to 1, alpha 2 of 0 is equal to 1, alpha 2 of 1 is equal to k1 into 1 plus k2, alpha 2 of 2 is equal to k2. So this is the assumption for the equation actually, okay. So therefore so for y2 of n we can consider like this, okay. For y2 of n we can assuming like this. So let us see here, y2 of n is equal to alpha 1 of 1 is alpha 2 of 0 is equal to 1, this one first value is 1, we don't have any constant. So this is nothing but alpha 2 of 1 is equal to k1 into 1 plus k2 and alpha 2 of 2 is equal to k2, okay. This is the values actually from this equation, okay, this equation, right. So after that then the equation for y2 of n is changes to, okay, the above equation y2 of n equation can be represented in terms of a alpha format, that is nothing but y2 of n is equal to, okay, y2 of n is equal to alpha 2 of 0 into x of n, alpha 2 of 1 into x of n minus 1, alpha 2 of x of n minus. So this is the only second order point of view. Suppose if you go for the real time scenario, there is a possibility of maximum number of orders is there. So at that situation we can represent this y2 of n can be in terms of a generalization format, that is nothing but here y2 of n is equal to summation k is equal to 0 to 2 alpha 2 of k into x of n minus k. So based on that value, suppose if you are substituting k is equal to 0, what happens is that alpha 2 of 0 into x of n, first term is satisfied. Suppose if you are substituting k is equal to 1, what happens, alpha 2 of 1 into x of n minus, it is also satisfied. If you substitute alpha k value is equal to, we can get alpha 2 of 2 into x of n. That means, so this principle is possible. Suppose if you closely observe this equation, it is in the form of a convolution format. Therefore in the general mth order FIR system, lattice structure can be represented as, suppose here we are considering only second order system consider chesam. Suppose if you go for the mth order system ane oka consideration point of view teeskoni manam equation ga represent chesamante, this is the format. Therefore the above equation, this equation can be look like a convolution, okay, convolution equation. Therefore by using that one we can apply this z transform, okay, so we can apply the z transform to the above equation. We can get ym of, okay, ym of z is equal to alpha m of z into x of, therefore ym of z by x of z is equal to alpha m of z, that is equal to the transfer function of the FIR system. It is very very important guys, transfer function of the FIR system. So the FIR filter having a system function given above is called as a forward prediction. Okay, this above transfer function is generally called as a forward prediction. Now we have to see what is the procedure. Okay, what is the procedure to realize the lattice structure of a FIR system? So for that purpose, see first point is nothing but if the coefficients of the present input, that is nothing but x of n, is not unity, convert it to unity by taking a common coefficient of the present input. అంటే మనకి ఇచ్చిన ఈక్వేషన్స్లో x of n పొజిషన్ కోఎఫిషియంట్ వాల్యూ కానీ లేదు అంటే దట్ మీన్స్ ఇట్ టర్మ్స్ ఆఫ్ 1 మైనస్ జెడ్ ఇన్వర్స్ ఆఫ్ x of n ఫార్మేట్లో ఉందంటే ఏదైతే కోఎఫిషియంట్ బిఫోర్ ఉంటుందో దాన్ని కామన్గా తీసేసి వీ కెన్ రిప్రజెంట్ x of n యాజ్ ఏ యూనిటీ కోఎఫిషియంట్గా మనం రిప్రజెంట్ చేయాలి. దట్ మీన్స్ వీ కెన్ కన్వర్ట్ in the format. Second thing is nothing but ఏమంటున్నాడు, find the order of the difference equation and compare the coefficients of the given difference equation with the coefficients of the same order lattice structure. ఓకే, ఇన్వాల్వింగ్ ద రిఫ్లెక్షన్ కోఎఫిషియంట్ K1 K2 అప్ టు 1. అంటే మనకి ఇచ్చిన ఈక్వేషన్ అనేది సెకండ్ ఆర్డర్ ఈక్వేషన్ ఫస్ట్ ఆర్డర్ ఈక్వేషన్. ఆబ్వియస్లీ యూ హ్యావ్ ఎ డౌట్, సార్ హౌ కెన్ యూ ఐడెంటిఫై ది ఆర్డర్ ఆఫ్ ది ఈక్వేషన్? Suppose if in that difference equation, if the number of elements is 2 or 3 is there, based on the number of delay elements, we can decide the order of the corresponding equation, right? Difference equation. So ఆ ఈక్వేషన్ కంపేర్ చేసి మనకున్న ట్రాన్స్ఫర్ ఫంక్షన్ జనరలైజేషన్ తీసుకొని కంపేర్ చేస్తే we can get K1, K2, K3 values, right? So assign the calculated values of K1, K2, K3 and construct the lattice structure. So K1, K2, 3 values బేస్ చేసుకొని lattice structure ని డిజైన్ చేయండి అని చెప్తున్నాడు. సో దట్ ఈస్ సో కమింగ్ టు ది అడ్వాంటేజెస్ పాయింట్ ఆఫ్ వ్యూ చూసారంటే ఇట్ ఈస్ వెరీ ఈజీ టు ప్రోగ్రామబుల్, బట్ number of adders and multipliers will be increased. So that is one of the drawback. So this we will discuss complete a very brief introduction and very depth introduction, very depth analysis of the lattice structure realization, right? So just I will give a very 1 minute revision. Lattice structure realization మనం ఏం చేస్తున్నాం, ఫస్ట్ ఈ lattice structure realization x of అనేది 2 పార్ట్స్ ద్వారా ట్రావెల్ అవుతుంది అనుకున్నాం, అంటే ప్రాసెస్ చేసింది అనుకున్నాం. అలా ప్రాసెస్ చేసిందంటే ఆబ్వియస్లీ మనకు కూడా 2 అవుట్పుట్స్ వస్తాయి. దాన్ని y1 of n అని y డాష్ ఆఫ్ n అని మనం రిప్రజెంట్ చేసాం. y1 of n ని రియల్ అవుట్పుట్ అని మెన్షన్ చేసాం. y డాష్ ఆఫ్ n అంటే దట్ ఈస్ నథింగ్ బట్ సపోర్టింగ్ అవుట్పుట్ ఫర్ ది నెక్స్ట్ స్టేజ్గా కన్సిడర్ చేసాం, రైట్? సో దాన్ని బేస్ చేసుకొని మనకి ఈక్వేషన్ y1 of n కి y2 of n కి ఈక్వేషన్ రాసాం. అట్ ది సేమ్ టైం వీ కెన్ డెవలప్ ది సెకండ్ ఆర్డర్ సిస్టమ్ తీసుకొని సెకండ్ ఆర్డర్ ఈక్వేషన్కి మనం y2 of n కి అండ్ y2 డాష్ ఆఫ్ n కి కూడా ఈక్వేషన్స్ రిప్రజెంట్ చేస్తాం ఇన్ టర్మ్స్ ఆఫ్ y1 of n లో. మనకి ఆల్రెడీ ఫస్ట్ ఆర్డర్ సిస్టంలో y1 of n కి ఈక్వేషన్స్ తెలుసు కాబట్టి బేస్డ్ ఆన్ దట్ ఈక్వేషన్ వీ కెన్ రిప్రజెంట్ కంప్లీట్ ఈక్వేషన్ y of n ఇన్ టర్మ్స్ ఆఫ్ ఏ సమ్ కాన్స్టెంట్ వీ విల్ కన్సిడర్ లైక్ K1 K2 అజంప్షన్ తీసుకొని వాటిని బేస్ చేసుకొని ఆల్ఫా 2 of 0 అండ్ ఆల్ఫా 2 of ఒక జనరలైజ్డ్ ఈక్వేషన్ రిప్రజెంట్ చేస్తాం. దట్ ఈస్ నథింగ్ బట్ ym of n is equal to summation k is equal to 0 to m alpha m of k ఇంటూ x of n మైనస్ కే ఒక జనరలైజ్డ్ ఈక్వేషన్ తీసుకున్నాం. దాన్ని ట్రాన్స్ఫర్ ఫంక్షన్ ఫార్మేట్లో రిప్రజెంట్ చేసి ప్రొసీజర్ ఎలా ఉంది అంటే మనం ఎలా క్యాలిక్యులేట్ చేయాలి, లాటిస్ స్ట్రక్చర్ డిజైన్ చేయాలంటే FIR సిస్టమ్కి ఏ ప్రాసెస్ ఫాలో అనేది జస్ట్ ఒక 3 steps చూసేసాం. ఓకే, సో దిస్ ఈజ్ ద వెరీ ఇంపార్టెంట్ క్వశ్చన్ ఫర్ external point of view guys. Okay, so thank you for watching GMK tutorials. Thank you all of you.